One of the relevant action inside of the 7Med Coast project was the assessment of the flooding scenarios due to the cumulative effect of storm surge events and sea level rising. High-resolution maps of flooding scenarios for sea level rise and storm surge in pilot site is the action E6 inside of the project 7Med Coast, and it is mainly addressed to make an assessment of which kind of scenarios we can rise during the cumulative effect of storm surge events and the sea level rising up due to the world climate change. The first things that we have to observe is that the assessment for the storm surge events and the characteristic of waves and climate waves has been obtained through the implementation of a Mediterranean Sea numerical model, obtaining homogeneous condition for all the pilot sites investigated inside of the project itself. Here you can have a quick imaging the LEFCAS, Nord LEFCAS, in which we have realized which is the climate wave condition, obtaining the time distribution in terms of return periods. This means the probability of occurrence of estimated wave 8 compared to the return times. This means an extreme events. And in fact, you can observe in this table that we have simulated 5 return times, 5 extreme conditions. Ordinary, 5, 20, 5, 50 and 100 years is the return time with the corresponding 8 of waves and the period of the waves itself. As well as we have information about the direction and intensity of the storm surge. This analysis has been performed for all the pilot areas. This is South LEFCAS and even for the Italian sites. The further analysis is to make a cumulative effect of the several components taken into account for the assessment of the sea level rise at 200,000 years. And as you can realize from this picture, you can have the condition for return time that is 1 year and return time that is 100 years. The first one is supposed to be the ordinary condition. This means the ordinary storm surge events cumulated to the forecasted sea level rising, while the second one is related to a really extreme events with 100 years of return times. All the components assessed for the RCP 2.6 and RCP 8.5 has been taken into account as extreme condition for static sea level rising, cumulated to the effect of the tide and the run-up due to the storm surge events. Thus, 4 scenarios have been created in order to separate the condition for the ordinary storm surge events cumulated to the both condition 2.6 and 8.5 RCP condition in terms of sea level rising. And the second one is for return time of 100 years with the both condition 2.6 and 8.5. These are a quick plot in which we would like to represent which is the area that has been submerged related to the scenarios that we have generated. In this case, what we can observe for the LEFCAS city is the condition for the return time 1 year with storm surge that is ordinary, with the condition for the sea level rising of RCP 2.6 that is more or less the total amount of 3.29 meters, and this is the extension evaluated in the first approximation of the area that has been submerged during this kind of events. On the other side, we have the same condition for storm surge events, but the condition for the sea level rise is related to the condition of RCP 8.5. These plots are referred to the same area with the storm surge condition related to 100 return times for both condition of RCP 2.6 and RCP 8.5. As you can realize, the extension of the area, the submerged area and the flooded area from storm surge and sea level rising is wider than before, and even in this table we can have quick information about the value of the storm surge event. This means the sea levels that we observe and the extension of the flooded area for both conditions.